All right, Algebra 2. I'm going to attempt to kind of wrap up what we had started in class on Monday with talking about the speed of the roller coaster at certain points. So if you remember, we kind of went through this example down here where we were looking at speed going up and down a couple hills. I'm going to do that one more time here with this new example just to kind of give you another chance to see how that works. So if you notice, I've got my polynomial here. First thing to point out once again is that because my polynomial begins at a y-intercept and then goes up, I'm going to need tracks right away. So that's going to be where, if you recall, we said we're going to travel at about 1 meter per second on those tracks. So that first interval, that's going to be kind of what you end up with. So really my calculations are going to start with my second interval, which is going to go from this point at 0.814 down to this point at 3.686. So along that interval, keep in mind the formula that we are using is that final velocity minus initial velocity is equal to acceleration multiplied by final time minus initial time. Now that being said, my final velocity is what I do not know. My initial velocity is going to be the 1 meter per second from my starting interval there. Now, if your graph starts by going down from your y-intercept, then your initial velocity is going to be 0. So maybe if your graph did something like this and then went up, then you'd be starting at initial velocity of 0 because you wouldn't have that first set of belts to take you up. So that's a little bit different than what we're looking at here. Now, acceleration. Remember, that's either going to be a positive 9.8 or a negative 9.8, depending on whether you're going up or down. If we're going down, then gravity is helping to speed up our roller coaster, in which case I'm going to use a positive 9.8. Now the final time is going to be that 3.686 minus my initial time, which my initial time is that 0.0814. So I'm going to put that in. I'm going to have to move over a little bit here to show that to you. So 0.0814. Okay. So if you notice, I've got that 3.686 minus 0.814. To get final velocity by itself, I'm just going to add the 1 to each side, so final velocity equals to 1 plus everything else that's up there, so 9.8, parentheses 3.686 minus 0.814. So then that's going to be what I type into my calculator here, is I'm going to take 1 plus 9.8 multiplied by, in parentheses, 3.686 minus 0.814 tells me that my final velocity, at least right now, is about 29.15 meters per second. Remember that friction, however, takes away 60%, so my final velocity is actually going to be about 40% of what we just calculated. In other words, my final velocity for this part is going to be about 11.66 meters per second. At which point I'm going to start to calculate my speed going up the next hill. So for my next hill, I'm going to be going from 3.686 up to 6,5, in which case I'm going to do those same calculations once again. I'm going to take V sub F minus, now in this case, you also need to keep in mind that you've got friction going up the hill. So I've actually got to take my answer and multiply by 0.4 one more time to get that my initial velocity going up this hill is going to be a measly 4.66 meters per second. So there's my initial velocity. Once again, you've got gravity, which is 9.8, parentheses, my final time is now 6, minus my initial time is 3.686. And then I'm going to solve for V sub F. So V sub F, I'm going to add the 4.66 to each side, 4.66. Now, if you notice, I kind of made a mistake up here. It should have been a negative 9.8 because I'm going up a hill, so my force of gravity is working against me. So I should have 4.66 minus 9.8 multiplied by, in parentheses, if you're to simplify that, would be 2.314. So when I type that in here, that 4.66 minus 9.8 multiplied by, in parentheses, 2.314 is going to get me an answer which is a negative. In other words, I'm not going to have enough speed to get up that next hill. When that happens, basically what you're going to have to do is scratch everything you've already done and replace a couple of things. You first need to figure out where you run out of speed. In other words, set your final velocity here to 0. So I'm going to say 0 minus 4.66 is equal to my negative 9.8 multiplied by in parentheses. Now what we're going to do is we're going to try to figure out what final time I run out of speed. So I'm going to put that as t sub f minus 3.686 and go ahead and start to solve backwards for this final time. So for this one, let's see, negative 4.66 equals negative 9.8 divided or multiplied by in parentheses t sub f minus 3.686. So let's divide by negative 9.8 on each side. See what we get there. So I'm going to take my negative 4.66. I won't be too picky with rounding, so you notice that I'm typing that in without all those extra decimals. Divided by negative 9.8, I get 0.48 is equal to t sub f minus 3.686, at which point I just add the 3.686 to each side, so I'll go ahead and do that now. Tells me that at 4.16 seconds, I run out of speed. That's my final time. Which basically means that I'm going to have belts. So 4.16 would be about kind of right in here. So this little stretch right there is good, but that means from 4.16 all the way up to 6, I now need to put in belts. Which again, those travel at 1 meter per second. I'll just write that in to remind us here. And then we've got one last interval to calculate where we're going to be going from our x value of 6 up to an x value of 7.163. So I'm going to set my final velocity minus, again, we used belts, so that's a 1. Now I've got gravity working for me because I'm going down, so a positive 9.8 multiplied by, in parentheses, 7.163 minus 6. Let's do some simplifying here, so let's add the 1 over. 1 plus 9.8. I'm going to simplify what's in parentheses as well to be a 1.163. And now I should have to just type that into my calculator. So let's see, 1 plus 9.8 multiplied by, in parentheses, 1.163. And I'm going to get a final answer here, my final velocity of 12.39. But wait a minute, hold on. We've got friction to take into account. So with friction accounted for, that gets me to where I'm at 4.96 meters per second as my final answer. Obviously, any of those that you want to convert to miles per hour, you're more than welcome to. But at that point, you would be done calculating speeds for your roller coaster. Now, if it had more kind of intervals or anything like that, you'd obviously have to keep going. But that would be kind of how you would calculate speeds throughout your roller coaster. That being said, guys, if you have any more questions, make sure and ask me tomorrow in class. Have a great